My name is Michael Caine. You may know me as Alfred from Christopher Nolan's Dark Knight trilogy. However, I'm a man that wears many hats, one of them being a calculus professor. So today I'm going to show you how you solve number 13 on the exam free review. Right, so the first thing we notice is it looks bloody weird, right? So that's a good sign that we've got to use one of our tests. And this one being the root test. Both the numerator and the denominator are both raised to the power of n. So we take the root. The nth root, that is. So we go ahead and plug this in as our an. And what I'm going to do is I'm going to get rid of this negative right here because we're taking the absolute value, so it's going to cancel out anyways. No need to bloody write it down. Right, so that's what we've got so far, right? Now, important thing to remember is that these little ends are just going to disappear. So let's go ahead and just erase those. We're going to just pretend all those cancel, right? So boom, 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 those cancel. Now this is what we're left with. And from here, you might be wondering, well, what's this little bugger? What's he doing, right? How are we going to deal with that? It's easy. It's bloody easy, I'll tell you. So we can remember that for values of n that get sufficiently large, we've got tangent, inverse tangent of n, right? And that little bugger, guess what? He's just going to go to pi over 2. It's a constant. So we're really dividing by pi over 2 with that one. So we can rewrite that and just erase all this. What we're really saying here is quite simple. And now, since we were divided, it's going to be multiplied by the reciprocal. But we've got 2 over pi times the limit. It's going to go to infinity, right? What do we have? N over n plus 1. Now, this little bugger, he's just going to spit out a 1, right? So that's our L right there. It's 2 over pi times 1, which is just 2 over pi. So our L is equal to 2 over pi. We all know some men just want to watch the series diverge. But because this is 2 over pi, we have determined that it does not diverge, it converges, right? Because pi is greater than 2, which means that this is a fraction less than 1. And the root test says that for R value, well, if you find L for something that you take the nth root of, then that means that it's got to converge absolutely as long as that limit is less than 1. So by the root test, and because this is our L, right, we've got that this series converges absolutely by, you guessed it, the root test. Now, isn't that incredible?